Hi everyone, and welcome back to the lab. In this video, I'll be showing you how to get dichloromethane from things you can find at the hardware store. Dichloromethane has the formula CH2Cl2 and can be represented by this structure here. You can notice that the chlorines are on opposite sides because, of course, of their electronegativity, which causes them to repel each other. So they mostly sit in this sort of a state, and that makes the molecule fairly nonpolar. Because it's nonpolar, of course, it does not dissolve in water, and because of its lightweight, it doesn't have a very high boiling point. So low boiling point, doesn't dissolve in water, makes a perfect extraction solvent. So it's very popular in organic labs to extract things with dichloromethane, since it can be easily removed from whatever you extracted because of its low boiling point, and it's fairly insoluble in water. The product you can find dichloromethane in is paint stripper. Usually paint strippers will either have dichloromethane or toluene or something like that, so you need to look at the back to make sure. But this brand here, this Clean Strip Premium Sprayable Stripper, happens to have dichloromethane in it. And in fact, you can verify this by either looking on the back or finding the MSDS. On the back, you can see here it says contains methanol and methylene chloride. Methylene chloride is the trade name for dichloromethane. It's sort of an older name that they use. And in fact, if you bring up the MSDS for this stuff, you'll find that it's 60 to 100% by weight dichloromethane and 10 to 20% by weight methanol. So also there's some polymeric goop in there, which I'll get to in a minute, that makes it sort of this sloppy, gooey stuff. So we're going to try today and distill the dichloromethane, or isolate the dichloromethane from this paint stripper. These two diagrams here represent the mixture of compounds we'll be distilling from the paint stripper. And the reason we'll be distilling first is because there's a bunch of polymer crap in the paint stripper, and if we go to try and do an extraction or something like that on it, the polymer is just going to get in the way. It's going to dirty up the glassware and contaminate the product. So the first order of business is to distill. I'll set up for simple distillation and take these two products, the methanol and the dichloromethane, off into a separate receiver. After I do that, we can go ahead and try and separate these two, and that's pretty easy because you'll notice that dichloromethane is fairly nonpolar, right? We have these two electronegative centers here on the side, and they sort of balance each other out and make the molecule fairly neutral, whereas in methanol, this lone pair of electrons on the oxygen creates a negative area over here, and the hydrogen, the proton that's on the hydroxyl group, creates a positive area over here. And because the chain of carbons is so small, that makes this molecule actually quite polar. It's soluble in all proportions in water, in fact, and dichloromethane exhibits fairly limited solubility in water. So what we'll do is we'll mix this with water, and all the methanol will go to the water layer, right, because the water's polar and attracted to it, and the dichloromethane, being less polar, will layer out. After a couple of rinses like that, we'll have removed substantially all the methanol from it, and we can go ahead and then just dry the dichloromethane over some drying agents. I think potassium carbonate should be suitable, and then we can go ahead and either redistill that or store it. But I think store it is appropriate because potassium carbonate has pretty much zero solubility in dichloromethane. So anyway, let's get to the lab and try it. Alright, so the first step will be to load a bunch of the paint stripper into this flask. It's still a little wet from washing, but that's not going to make a difference here. I've got a 1 liter flask and my heating mantle here, and we'll just go ahead and put a funnel on that, and then I'll pour in some of this lovely gloopy paint stripper, and you can see what I mean by gloopy. Alright, there we go. You can see the flask is about half full with dichloromethane containing goop, polymer and crap, and I'll go ahead and set this up for simple distillation, and we'll get that started. Alright, so I've set it for simple distillation. You can see I've got here my 1 liter heating mantle with a jack underneath it. I've got the flask with the paint stripper in it with a standard still head, all 2440, and this is a thermometer well. We're not actually going to take the temperature because it's not really going to tell us much. There's really no point. I have a 300 millimeter Liebig condenser ready to condense the dichloromethane and methanol vapors. The reason I chose 300 millimeters over my standard 200 is because dichloromethane and methanol both have fairly low boiling points, and the long condenser will help make sure the condensation process is efficient. So anyway, down here I've got a standard vacuum adapter. Remember, never heat a closed system. This is the opening in this particular system, and a 500 milliliter collection flask for the mixture that we will be distilling over. Now, I'm not going to distill this to dryness or anything. I'm just going to distill it until it either starts foaming or bubbling or looking like it might be hard to take out. So this isn't going to be a particular, we're not trying to get 100% yield out of this. We're just trying to get dichloromethane in a very easy way. So that said, let's turn the mantle on, get the heating going, and they should start boiling any minute. The paint stripper is now boiling, and the vapors are traveling through the head and into the condenser. You can see we're using pretty much all of the condenser. The vapor front doesn't really stop till about halfway down, and we are pulling off dichloromethane at a ridiculous pace right now. That's actually a little faster than I want, so I turned the heat down just slightly, but we'll be stripping this paint stripper in no time. And Yeah, I don't think it'll be more than maybe 20 minutes for this one. But we'll see what happens near the end. And it looks like the distillation is wrapping up. That's getting awfully thick, and I think it's going to be a bit difficult to get out of the flask, so I'm going to go ahead and stop now. Besides, I think that judging by the change in consistency of the liquid condensing in the condenser, and you can kind of tell, remember before it was sort of making beads, and now it's sort of a continuous sheet, that sort of indicates that that's probably methanol coming over rather than dichloromethane, just sort of a thing that experience tells you. Anyway, so we're mostly done, and you can see that the flask is pretty much full, about 3/4 full. It's about as full as you want to use these flasks anyway. So I'm going to go ahead and stop the distillation, turn off the heat and lower the mantle, and after this cools sufficiently to stop distilling product, we can go ahead with processing the mixture. The product of the distillation is approximately 400 milliliters of a very dense liquid, and this is characteristic of a lot of chlorinated solvents. They have very high density, so this feels much heavier than it would be if it was water, for instance. Of course, this is a mixture of dichloromethane and methanol, and we'll now proceed to wash the methanol out of it using this handy-dandy SEP funnel here. So what I'm going to do, essentially, is just pour the dichloromethane into the funnel using another funnel. And make sure the stopcock is closed, right? Amateur mistake, don't make that. Alright, now I'll add a little bit of water, and remember the water is going to act to absorb the methanol. So we'll get a good layer going on there. That's about good, and you can see the dichloromethane is much heavier than the water, and the water is now floating on top of the biphasic mixture there, and the methanol is now rapidly being absorbed by the water. So to help that along, I am going to seal this up and shake it. And dichloromethane has a fairly high vapor pressure, so it tends to blow out stoppers and things like that. So you have to be very careful and make sure that when you're shaking this, you vent often. Now this is a special type of SEP funnel, which happens to have a vent. If you look here, there's a little vent hole there, and if I line up this ridge in the stopcock with the vent hole, I can vent it like that, just by turning this a little bit, rather than having to flip it upside down and vent it using the stopcock. So I'm just going to go ahead and do that. I can feel the pressure building up. And we'll give that a minute or two to settle back out. Alright, you can see the mixture is mostly settled. The dichloromethane layer is a little cloudy because it's taken on some water, but that will go away in a later step. And now the methanol is located in the water layer. So what we'll do is we'll just drain off the top layer, we'll drain off the bottom layer and keep that, and then discard the top layer since it's just methanol and water. There we go. So here is the dichloromethane. It is a little wet, as you can see, and we have our first wash of water, which I will be putting in a chlorinated waste bin. So we'll be emptying it into this separate container over here. And now to add the dichloromethane back to the funnel, of course making sure the stopcock is closed. And I'm just going to repeat this process 2 more times. You can see that the second time the water layers out much more quickly, which indicates that this layer is now extremely hydrophobic, and that's because we've washed most of the methanol out the first washing. But this and one additional washing should separate it nearly completely. So just shake this up. Anyways, begin to decorate it. Alright, this is the dichloromethane after the last wash, and you can see that it's fairly pure. There's no methanol in it, but it's got quite a bit of water, and that's what's causing the cloudiness, and also you can see there's some beads on the top here, and that's artifacts from using the SEP funnel. The SEP funnel will form a vortex near the end and things like that, so we have a little bit of water in that, but no fear, it's easy to clean out. We're going to do that with some technical grade potassium carbonate. So all I'm going to do is add a few spoonfuls of potassium carbonate to this, and I'll shake it up. And it's almost like a magic trick where this will go from cloudy to clear in a couple of seconds. So let's do that. Just a couple of good spoonfuls. And I can already see it's clarified, but I wanted to show it up close, but you can see actually now how much clearer it is already. But I'm just going to shake this around, again venting often. Get the potassium chloride, or sorry, the potassium carbonate mixed in, and you can see it sort of clumps up in the presence of water, but we are very quickly removing the water from this dichloromethane. As you can see, it's becoming quite clear. Alright, so here's the final product, about 350 milliliters of dried dichloromethane. I'm just going to simply pour this into the storage bottle. And I'm going to be careful not to get any of the desiccant in there. So here's the product of the evening's work. It's about 350 milliliters of dichloromethane that is pure enough for 99% of the uses you'll need dichloromethane for. Further, if you need dichloromethane that's more pure than this, you'd probably distill the stuff that you purchased anyway, so there's really no sense in repurifying this by distilling and all sorts of stuff like that. It's really just a waste of time. So anyway, if you like this video, please press the like button. If you'd like to donate $1 or $2 to help me continue to make these videos, I do have a Patreon account. I'll put the link in the description. I don't get paid for all my videos, note that. This video didn't cost me very much money, so I'm not claiming any money on it, but the videos I do make that I need help with, paying for, that is, they'll cost me hundreds of dollars sometimes, I do claim the money for. So rest assured that you guys have been so cool to me, I'm going to be cool right back to you, and I'm only going to claim money on cool videos. However, I do want to show some of the more basic stuff, like this video, so I'm going to make them anyway, just not get paid for them. So anyway, if you liked the video, like I said, hit the like button, subscribe if you want to see more. I got a lot more videos coming, and as always, thanks very much for watching.